Welcome back. So I guess that we have tried to sketch the problems like this in the very first video to solve this problem 16, right? And then we have spent time to review the concepts that related to the work energy theorem and also on the work itself from the two previous videos. And this is the summary of it. I have it written here. Like the work energy theorem is basically tells the relationship between the work done by total forces acting on an object, and that will equals to the change in the kinetic energy. Change means that the final minus the initial, and the kinetic energy will be the energy of something when it's in motion, when it's moving at a speed v, a velocity v, and with the magnitude is the speed v squared times with the mass, and half of it, that will be the kinetic energy. And then we also have a review about work, that how to calculate work. So work is just a quantity to show how the forces have add energy to the object when it's have moved for a displacement s, or it can be remove the energy from the object. And how is this defined? Work is defined as equals to the magnitude of the force times with the displacement, just the magnitude of the displacement, and the cosine between them. Because actually we just want to see how only the component that in the directions of the displacement that will contribute to the motion in that direction. So just be careful that force is a vector and displacement is also a vector, but then work is just a scalar. It's just a scalar when we just have the magnitude of the force times with the magnitude of the displacement. So that's everything for the concepts that we need to solve these problems, and those are also the equation that we need, right? For now, we just need to see, oh, how can I apply these to our problems here, how to solve it. So I could say that at first, let's plan. Let's see how we can solve this problem and find the logic at first. We don't need to bother there with the numbers and the values, but let's see what can we do, okay? Where to start? So let's say use the work energy theorem. So I use this one, to find the rock speed just as it left the route. Oh, so if it just as it left the route, it should be somewhere here, right? Just when it left the route here. And they ask us to find the speed there. Okay, so okay, where to start? They want us to start with to calculate some speed here. And what is given? Okay, so the thing is that look at the clue, like the hint, the clues. What is given here in this problem? Okay, they give us is a 25 Newton rock. 20 Newton rock. So if it's a 20 Newton rock, that should be like the weight of the rock, right? Let's summarize on the numbers, like the number, because in the end we need to providing them an answer with number. So let's just summarize on the value, on the numbers they have in the problem statement. 15 meters high, this is this position, that will be height to be 15 meters. Okay, oh, I will put it follow there. Precision 15.0 meter. The velocity over there is 25.0 meter per second. Okay, so we are given three values, three numbers, and then they ask us to find the v here. I'm thinking that we need to find this one. So if we want to use this one, then we need to know the change in kinetic energy, right? Oh yeah. So you see the change. So if it's about some change it should have some initial point to a final point, initial to a final, and this should be some motion and also some displacement, right? So is there any displacement here in this problem? There is, right? Oh, and actually in this case, it's not a motion horizontally, but it's actually a vertical motion, right? Yeah. And actually, can you tell that this is the initial point, right? If we want to see, then the v they ask us to find actually a initial v, an initial velocity, a u. They ask us to find a u. Do we know anything about? Oh, we also know the v here. Wait, okay, so we also know the v here is the final one. They ask for the initial one. Do we have the mass to calculate the ke? For the mass, right? We need the mass. They don't give us the mass, but they give us the weight. Can you think of some relationship between weight and mass? Okay, you got it, right? Okay, so that's equals to mg, and g is the gravitational acceleration or the gravitational field strength within 9.8 meter per second square. So from this one we can find the mass, right? Yay, we can find the mass, and then together with the v here we can find the kinetic energy final. Okay, so seems that we can get the final kinetic energy, but they ask us to find the u. So in order to find the u, we need the initial kinetic energy. But can we find that? If we can find the work, right? Because like for this one, we if we know the this part, the left side, we know this one, and we can find this one, and then from this one we can find the u. Interesting. So now we need to find the work. We need to find the work. Okay, so when it travel upward like this, which force is acting on the rock? Which one? They didn't mention anything about air resistance here, right? Okay, so in this case, the air resistance, when you see that it doesn't mention, then it will be like negligible. So it means that we just don't care about it. It just like go to zero, kinda. So in this case, if you throw something, you actually just apply a force at this moment. When it left your hand, you don't apply any force on it anymore, right? Because you're not in contact with the force, with the rock anymore. So there's no more force from you. You just provide an initial velocity here from the force that you throw the rock, but not after that. So when the rock travels through air, which force is acting on it? When the forces travel in the air, just in the air, and we don't have the air resistance, but we know there's a crowd here, and the crowd here means that it is on the surface of the earth, right? Yay. So can you identify which force is acting on the rock? Yep, I think that you got the answers right. Yep, that's the gravity. That's the gravity. Or actually the weight itself, right? That's the weight of the rock, is the force. Okay, so now seems that we identify the weight is the force acting on the rock when it's moving upward. Then we can find the work, right? And from the work done, then we can find the change in the kinetic energy because they equal to each other through the work energy theorem. From this one, then together with the final velocity at that height 50 meter, we can find the ke initial, and then from this one we can find the initial speed. Sounds good? Can you see the logic of our work? Okay, so I could say that maybe it's not that easy and very straightforward from the first time when you solve this problem, but you see the logic I'm trying to make sense here. that we start from what they ask us, we summarize the problem, see the numbers given, and then try to connect the dots, and then we can see this is the logic. Okay, so in the next video, let me try to clean the board a little bit, and then we can work together to solve this problem and present them in a logic way rather than just too much like my handwriting is here. But does it make sense to you? Please let me know, okay? I'm happy and willing to answer any questions in your comments. Thank you. See you soon.